Very good morning, dear students. So today our topic is we have started a new chapter, that is hydrocarbons. So what are hydrocarbons? So hydrocarbons are actually the organic compounds containing carbon and hydrogen only. These are the organic compounds which are consists of carbon and hydrogen only. So these are called as hydrocarbons. Clear? So hydrocarbons are actually two types. There are two types of hydrocarbons. One is saturated hydrocarbon, one is unsaturated hydrocarbon. Saturated hydrocarbons are those which contain carbon-carbon single bond, and unsaturated hydrocarbons are those which contain carbon-carbon multiple bonds. So that is carbon-carbon double bond or carbon-carbon triple bond. Clear? So saturated hydrocarbons which contain carbon-carbon single bonds only, these are called as alkanes. Unsaturated hydrocarbons which contain carbon-carbon double bonds are called as alkenes, and unsaturated hydrocarbons which contain carbon-carbon triple bond are called as alkynes. Okay, clear? So general formula of alkanes is CnH2n plus 2, where the general formula of alkenes is CnH2n, and general formula of alkynes is CnH2n minus 2. Here the number n starts from 1, 2 to so on. Here n starts from 2, and also here n starts from 2, 3, 4, so on, so on. Okay, clearly? So here for the alkanes, for IP, in order to write the IPS name, we are writing the specs, primary specs using N. Here primary specs is used at ene in case of alkenes, and in case of alkynes it is used at yne. Clear? So by giving the numbering of the carbon atom, here carbon, when n is equal to 1, due to numbering it becomes C1 H2 into 1 plus 2. The first member of the alkanes is methane. Similarly, you may give the another number to that of hydrocarbon is n is equal to 2, gives C2H2 into 2 plus 2 is equal to, that is C2H6. Similarly, you can give the number n is equal to 3, the member will become C3H2 into 3 plus 2, that is C3H8. Clear? इसी तरह से आप क्या करोगे काम, you will give the numbering to from n to n, and when the n gets increases, the number of members in a particular homologous series will get as increases. So there is a methane, ethane, propane, you will give n is equal to 4, butane. When n is equal to 5, it gives pentane, n is equal to 6, it will give hexane. Clear? Similarly, for the alkenes, when you start from the n is equal to 2, it becomes C2 H2 into 2. So first member it becomes C2H4. For alkenes, and n is equal to 3, it gives C3H4. When n is equal to 4, it gives C4H6, and so on. When you give the numbering, you will get the number of, you will get the analogous member of the alkenes. Similarly, you will see that here that for alkynes, when you give the numbering to n is equal from n is equal to 2 to the first member, it will be Cn, that is C2H2 into 2 minus 2, it will become C2H2. So this is called as a ethyne. Similarly, you will n is equal to 3, it gives C3H4, it is propine. Clear? Accordingly, so on, where you give the number n is equal to 4, you will form the butane. So accordingly, you will see the number of members will get increasing by giving the number to successive number. Clear? But one thing you must remember that from the analogous members, for example, methane to ethane, there is a difference of CH2. Clear? Or we may say the difference of 14 unified. For example, carbon having mass 12 plus 2 hydrogen atoms having mass of 2, so it will become 14 unified. 14 unified. So analogous members having difference of CH2 or 14 unified are called as homologous series. So analogous members, you will see here that all the members will, when you give the numbering from n equal to 1 to so on, you will see there the individual members will have the difference of CH2 or 14 unified. So these are called as a homologous series. So here the first homologous series will be formed from the alkanes. Second homologous series will be found from the alkenes. For example, for alkenes you will see that first member is called as ethene because n starts from 2 to n equals 3 to so on, and you will see the difference between the members. Analogous members will be CH2, C2H4 to C3H4. Well, while going from C2H4 to C3H4, you will see there is a difference of CH2 or 14 unified. So in this case also you will see the difference of the analogous member is CH2 or 14 unified, though this will form the another homologous series, that's called the alkenes will be form the another homologous series. Clear? Similarly, for the alkynes we will start the numbering from n equal to 2. So we make first member will be C2H2 into minus 2, so it will become the C2H2 because they contain carbon-carbon triple bonds. So first member is called as ethyne. Clear? Second member will be called as propyne. Clear? Accordingly, when you see the difference between the analogous members, you will see there is a difference of CH2, or we may say it is a 14 unified. So when there is a difference of CH2 or 14 unified, so this it forms the homologous series. The homologous series is the series of analogous compounds where the members have difference of CH2 or 14 unified. Clear? So here we have just seen that for alkanes, so first for example, when by writing the IUPAC nomenclature of these compounds, so when carbon number is 1, so it is word root will be meth, and when carbon number is 2, word root will be eth, and when carbon number is 3, and word root will be prop. Clear? And for alkanes, primary suffix is ane. You will add the ane here for all the members, but you must know we have already discussed in the IUPAC nomenclature. So this number of carbon atoms will indicate their word root. Whether it is a one carbon, when there is one carbon there is meth, when there are two carbon atoms then it is eth, and when there are three carbon atoms in the main chain then it is a prop. Accordingly you will say but, pent, hex, hept, and you are adding the ane here, the primary suffix, writing the IUPAC nomenclature. Similarly, in case of alkenes, you will see here that when there is a second member, that is carbon number is 2, to me first member for first member word root will be eth. Clear? And secondary suffix for alkenes is ene, so you will add ene here. So ethene first will be the first member. Second, similarly, when carbon number is 3 in the main chain, so what will the word root? It will be prop, and you will add the primary suffix ene, so it will become propene. Similarly, for carbon number 4, it will become but, and word root will be but, and primary suffix will be ene. Clear? So it will be butene. Clear? So as we have learned in the IUPAC nomenclature how to write the nomenclature of this compound. Similarly, for the alkynes, n is equal to 2, so it is word root will be eth. Clear? and its specs is Y and E, so it is ethine. Clear? When N is equal to 3, the word root will be prop. We have already discussed it, and it is primary specs will be wine. It will be propine. Clear? Similarly, will be butane, pentane, hexane, heptane. As you go for giving the numbering of when the n increases, you will get different number of analogous series. So we'll see here that different number of homologous series, homologous series for the alkanes will be formed here, and for the homologous series for alkenes, and this is for the homologous series for alkynes, because each the analogous member have difference of CH2 or 14 unified. Similarly, for this there is also difference of CH2, and there is also member of CH2 or 14 unified. Clear? So this is how the homologous series can be prepared. So this is a homologous series for, and their nomenclature. This is methane, ethane, propane, butane, pentane. Similarly will be ethene, propene, butane, pentene, accordingly hexene, heptene. Okay. For this there will be also the ethine, propane, butane, pentane. Clear? So for in, in order to write the structure of the compound, for example, we have for alkanes, we have the first member, that is CH4. So we know that in case of methane, when carbon atom, we know for carbon atom having atomic number 6, so its electronic configuration will be carbon having atomic number 6, electronic configuration will be simple electronic configuration will be 2 and 4. It means that it is valence shell contain 4 electrons. 4 electrons. So its valency will be 4. But in order to get stable, or to become to complete its octet here, it may either lose these 4 electrons or gain another 4 electrons to complete its octet. Yani octet means lost shell must contain number of electrons will be 8. So valence shell contain, even there is a 8 number of electrons in their valence shell, though it becomes stable. But for the case of methane, in case of carbon, carbon does not have tendency to accept the 4 electrons, or to lose all the 4 electrons here to become stable. So what will happen to carbon having the special property of, that is self linkage, that is catenation. Catenation means how it catenation occur. Actually carbon neither loses the 4 electrons, neither gains the 4 electrons completely, but it shows a mutual sharing of electrons. It shows mutual sharing of electrons to form an important type of bond that is called as a covalent bond. So carbon, because it shares the electrons, for example in case of methane, carbon having only 4 valence electrons. So how to complete its octet, it undergoes mutual sharing with this 4 hydrogen atoms. So each hydrogen atom contains 1 valence electron. So each hydrogen atom comes here to form the covalent bond with the carbon by mutual sharing. That is, both the carbon as well as hydrogen gets benefited. Similarly you will see here that is draw again. So carbon contains 4 valence electrons in methane, and 4 hydrogen atoms come here. First hydrogen come with 1 electron, so it by undergoes mutual sharing with the carbon, and it forms a bond that is called as a covalent bond. That is one type of covalent bond. Similarly another hydrogen will come, it forms a here covalent bond by mutual sharing. Third hydrogen will come from the mutual sharing forms a covalent bond. Fourth hydrogen will come to, it also undergoes mutual sharing with this carbon, and it forms what is called as a covalent bond. Clear? So it means that the bond is formed by 2 electrons. So each bond is formed by 2 electrons, but here the hydrogen gets duplicate. So here hydrogen gets duplicate means it gets stable. This hydrogen also gets two electrons in the outer shell, so it also gets two outer electrons, and it also complete. It is duplet. So duplet of the hydrogen gets here. But what the case of what will be the case of carbon? For carbon, you see here that carbon will have number of electrons will be 8. 2 to 4 plus 2 हो गए 6, 6 plus 2 हो गए 8. It means that carbon will have now octet 8 number of electrons. So in this methane the carbon gets it is complete number octet, so it became stable here. So this by mutual sharing, both carbon as well as hydrogen here get stable. Hydrogen gets duplet and carbon gets octet. It means it gets 8 number of electrons in it is outer shell. So both get stable. So this is why the carbon forms the covalent bonds with hydrogen. So in methane you will see that there will be 4 bonds with the carbon will form 4 bonds with 4 hydrogen atoms. Clear? Similarly, the second member, what will be the second member? C2H6. So first you will write carbon will show undergoes under in mutual sharing with second carbon atom. Clear? Because each carbon atom contains 4 valence electrons. So here the one electron is gets mutual shared with this carbon, and they form the bond that's called as a covalent bond, and rest of the valencies are fulfilled by hydrogen. So one hydrogen comes here, one hydrogen comes here, one hydrogen comes here. Similarly you will see here that six hydrogen are coming in, six hydrogen atoms are coming, and they form the covalent bond with these two carbon atoms. So there is results the formation of 4 covalent bonds. So here is the first covalent bond, second, third, fourth, fifth, sixth. So in this case the molecule will be C2H6, that is called as ethane. Clear? Because there is no carbon carbon double bond. Clear? So this is structure of ethane molecule. Clearly? Similarly you will write the structure of propane having carbon. How many number of carbon atoms? There are 3 carbon atoms. So first carbon atom, second carbon atom, third carbon atom, they will show mutual sharing because each carbon atom will have 4 valence electrons. So one electron will undergoes mutual sharing with this carbon atom to form the one single bond. Sorry, so this is actually single bond. So there is single bond here. So these 3 carbon atoms by mutual sharing result in the formation of 3 covalent bonds, and rest of the valencies are fulfilled by hydrogen atom. So here the hydrogen atom comes and they form the bond with these carbon atoms. So in hydrocarbons you will see the compound or molecule is made up of only carbon and hydrogen atoms. So the molecule will become, so they form the covalent bond here by mutual sharing and molecule will become C3H6. Clear? So there will sorry C3H8, C3H8. So number of hydrogen atoms will be 3 plus 2, 5 plus 3, 8. So C3H8 is what is the name of the compound? It is a propane. So alkane, when it contains 3 carbon atoms, so it will become propane. Clear? So this is the structure of the propane molecule. Clear? But you must have seen that while forming the alkanes only contain carbon carbon single bond. Clear? Rest of the molecule, for example ethane forms 4 covalent bonds, three covalent bonds with 3 hydrogen atoms, and one covalent bond with this carbon atom. Clear? So this type of covalent bond, there are 2 types of actually covalent bonds. Covalent bonds are 2 types. One is sigma bond and one is pi bond. So actually here the carbon combines with this carbon to form as the bond that is called as a sigma bond. So actually there occur when we see the orbital overlapping of the carbon atoms, there is head-to-head overlapping. Clear? So as a result, there is the formation of what there is or is the formation of sigma bond. So there are four sigma bond. There are 1, 2, 3, 4, 5, 6, 7. 7 sigma bonds are formed in case of ethane molecule. Clear? So there is no any double bond, there is only sigma bonds present. So one type of covalent bond is called a sigma bond, where there is a head to head collision of overlapping of orbital hybridized orbitals. Clear? So similarly you will see for this alkene. So here in first member is C2H4. So first you will write two carbon atoms, and in between the carbon atoms there is double bond. We know there for the for this carbon atom there are four valence electrons. So there four valence electrons will be written like as that this, because here the carbon contain multiple bonds. That is in case of alkenes there are double bonds. So here two electrons form one bond, two electrons form one bond. So there is a formation of double bond between these carbon atoms. The rest of the valencies is fulfilled by hydrogen atoms. So here is a hydrogen atoms comes and fulfills the rest of the valencies. As a result of which you will see the formation of first member that is called as ethene. Clear? It is a ethene molecule is formed by mutual sharing of the carbon when the carbon and mutual sharing of electrons result in the formation of covalent bonds. But in case of this carbon double bond, one bond is among these double bonds, one bond is sigma bond and another bond is pi bond. So among two bonds, one bond is sigma bond, sorry, this is sigma bond, and one type is called as a pi bond. So sigma bond is strong bond and pi bond is a weaker bond. Sigma bond occur by overlapping of orbitals by head-to-head collision of the orbitals. But this pi bond is actually is formed by the unhybridized orbitals. They undergo sidewise overlapping, just like as this. We will see on later on when we discuss the hybridization of these molecules. So these actually pi bonds are formed by the lateral overlapping of the unhybridized orbitals. Clear? So similarly for the alkynes you will see the first member is C2H2. So you will form here there are two carbon atoms and there are four valence electrons. So we know that there are three bonds here. So you will see here there's three valence electrons. So one bond forward, second, third. So result in the formation of how many bonds? So here rest of the valence is filled by hydrogen. So member will become C2H2. The C2H2 is the first member here. Clear? So this called as what? This called the ethyne. This called as ethyne. Clear? So here we will see that there is a formation of triple bond between carbon and carbon. But among these triple bonds, two bonds will be pi bonds and one bond will be sigma bond. Clear? So these will be the pi bonds above and below, and one will be the sigma bond. So this is how the bonding in case of alkanes and alkenes and alkynes. So tomorrow we will discuss about some how the actual this molecule is formed. That we will discuss the hybridization of methane, ethene and ethyne. Clear? So we will see the orbital picture how the molecule is actually formed. Hope you understand.